Okay, welcome back to a very rare early morning video. We're going to continue with the Python for DevOps book, and I will make sure to actually share my screen this time. So this is just the OBS interface, so I'm going to move this down because I'm sharing my second screen. Okay, so in the last video, we got through the section on Azure. We got most of it to work. We were in the Azure command line. We were trying to log into Azure. We created an account in Azure. That was fine. But in order to use any of the features of Azure, whether paid or not, you need to enter a credit card. And that just kind of is something I'm not prepared to do right now. Eventually, I might be more comfortable with that. But if I don't have to, I'd rather not. And Azure is not, for me, learning Azure is not really the most important thing. So we're going to just move on to the next section. This is deploying a Python function to self-hosted FaaS platforms. As mentioned earlier in this chapter, many FaaS platforms are running on top of Kubernetes clusters. One advantage of this approach is that the functions you deploy run as regular Docker containers inside Kubernetes. So you can use your existing Kubernetes tooling, especially when it comes to observability, monitoring, logging, and tracing. Another advantage is potential cost savings by running your serverless functions as containers inside an existing Kubernetes cluster. You can use the existing capacity of the cluster and not pay per function call as you would if you deployed your functions to a third-party FaaS platform. In this section, we consider one of these platforms, OpenFaaS. Some other examples of similar FaaS platforms running on Kubernetes include the following. So let's open this link. This will probably take us to the documentation. One thing interesting I'm noticing right away about this page is we've got a whale tail here that actually looks to me to be pretty similar to the Docker. Yeah, so here's the Docker logo. It's a whale with shipping containers on the top, so a bunch of squares. And this logo, we also have a whale with squares on the top. So leads me to believe that this is in some ways related to Docker, perhaps conceptually or through development or development team or something like that. But anyways, we might come back to that later on. For now, let's just continue. These are some other examples of FaaS platforms: Kubeless, FN Project, the Oracle FaaS offering called Oracle Functions, Fission, and Apache OpenWhisk. Deploying Python function to FaaS. For this example, we use a Kubernetes Lite distribution from Rancher called K3s. We use K3s instead of Minikube to showcase the wide variety of tools available in the Kubernetes ecosystem. Start by running the K3sup utility to provision a K3s Kubernetes cluster on an Ubuntu EC2 instance. Okay, so this is one of the main problems I'm having with this book. I don't have an Ubuntu EC2 instance, so I've been trying to get everything to work without that. I thought it wouldn't be too difficult to just use my home lab to replace Amazon EC2 because in my home lab I could just spin up any Ubuntu server. It's going to have a lot of delay because I'm accessing it remotely, but it will save me the hassle of creating this, at least I thought, but I just couldn't, example after example, I just couldn't get it to work doing it that way. So for this one, I guess what I want to do is try this on my local machine. So we're going to do that, but I'm going to do it in its own folder so that if something goes wrong with it, I can just delete the folder from my machine. So I'll just do it right here in my present working directory for my username. And unfortunately I can't copy paste these commands just because I'm reading it with Cloud Reader, Kindle Cloud Reader, but sometimes I prefer to get things under my fingers anyways. Okay, so download complete. That was successful. Let's look at the next command. Okay, so we're missing a part of this command. It looks like this second line here is meant to be just all one line. Okay, so we've got a problem here. No such file or directory. We're going to need to create this before we can move stuff to it. So let's do that. Permission denied, so that means sudo. There we go, and we've got it. So we'll run that command again. Now that we have the folder, there should be no issues copying things over to it. It looks like I've got no such file or directory for K3SUP, which is surprising, especially since we see it right here. So I wonder if oh, you know what? Maybe I need to change directory into that. Now it's in green, so I don't think it's a directory. Yeah, it's an executable. If I do an ls-al, or even a tree, we'll probably, let's just do an ls-l, or an ll. It's automatically there. So clear ll, and then we've got there we go. Not sure what this is, but let's try copying it over just without this -Darwin. There you go, and follow along, and hopefully things work out for me. Now one thing I wanted to do that I actually forgot to do is create a new folder just in this space so that I can delete it when I'm done in case anything goes wrong. So I guess I'm gonna, you know what, it's probably fine in here. I'm just gonna leave it in there. Alright, so next step is to verify connectivity into the remote EC2 instance. We don't need to do that because this is all on my local instance. So we're going to do this next command, K3SUP install, and we'll give it a local IP 172.0.0.1 user. We'll give it my username. Okay, so it looks like we don't have that command, k3sup. I do see k3sup listed here. Okay, so it looks like we need, I wonder if even if I do sudo now, but if I do this, I think it'll work. Yep. So I'm not sure why this is necessary sometimes. I think you need that in order to run an executable like that. So let's search for that. So we're gonna do Ubuntu Y. There we go. So Y is not the best search term to be in there. Here we go. Command. So yeah, these should probably be good enough. Okay, nothing there. Nothing there. Nothing there. Nothing. 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 Okay, so let's try the search again. So we're going to do Ubuntu. And then that in quotes. Interesting. Perfect. Here we go. So, oh, this is so nice. You know what? I'm gonna add this to my career developments because this is gonna be. I'm gonna have to come back to this again and again and again. So yeah, this is really good. So we can see you have to, after this sequence of characters, the period and the forward slash, you have to feed it an executable, which we did, and then the result of this will be to run an executable in the current directory that is not in your path. So that's why we couldn't run it just without doing this, because our path, which hopefully we'll get a good explanation of that, was not set up yet for it. So before I do anything else, I'm going to bookmark this to my career development folder. All right, and then we're going to read a little bit about path, because for me it's a little bit unclear. So we'll just stick to this Unix and Unix-like. So I think this will be all we need to read. When a command name is specified by the user or an exec call is made from a program, the system searches through $path, which I think we can get if we do a $echo. So open a new window here and then do, let's just do $path. There we go. And now this prints out where it's going to search. So examining each directory from left to right in the list, look for a file name that matches the command name. Once found, the program is executed as a child process. Okay, so one thing we can do, and I'm going to demo this, so we can see where it's searching to run executables. So I can go and cancel this, and now I can make it so that I don't need these characters anymore if I copy this executable to the folder that is searched for in path. So we can see here is a location. Here's another location, /user/local/sbin. It looks like there's multiple locations, and each location is separated by this colon sign. So we've got many places we can choose. Let's put it in this one here, this .local. That's where I want to do it. So we're going to do copy K3 SCP, and then we're going to copy it to there, which is in our path. So now I can up arrow back to the command, remove that, and now it runs without those additional characters because it found the executable file in these path folders here. Oh, I almost drank a bottle of supplements. All right, so we did everything here. The next step is to inspect the kube config file. When it comes to inspecting files, I like to use Visual Studio, but sometimes it's hard to navigate in Visual Studio. So I'll just open a new terminal. I'm the kind of guy, I like to really restrict my views down. So if all I'm doing is trying to find a file, I want to use the smallest application possible to do that, a command line instead of a Visual Studio. I mean, I'm sure it's fine to open Visual Studio and do that, but I guess I'd rather not. Okay, so let's, oh, you know what? It's probably in my, if I go to .local, /to bin, So I don't see this file, this kubeconfig file. Let's do a search for it. So find /name, kubeconfig. We've got a few locations here that are denied to search from, or just one it looks like. While we're doing that, we can do a top to see how taxing that command is. So it looks like it's the fourth most taxing thing. First is OBS, which makes sense. But it's hardly taxing anything. I guess that's somewhat taxing, but not too bad. This is what I really like about Ubuntu, is if you want to know how taxing something you're doing is or anything like that, it's just so easy to do that. Like I think Linux has a reputation among non-technical people that it's hard to use. But I mean, the reason why technical people love it so much is because it's easier to use for a lot of stuff. Where it gets this reputation for being difficult is it just allows you to do so many more things that some of those things it allows you to do are legitimately difficult. Whereas Windows just makes everything difficult, and most people who use Windows just never dive into those more difficult concepts, and they just get used to using Windows because they haven't tried anything else. And then by the time they go and try Linux, they've been using Windows their whole life, and now Linux is really hard because they have to learn a few really simple things. All right, so I just don't think I have that file. Gave it plenty of time to search through and didn't find it. So we can skip this, inspecting the kubeconfig file, and hopefully move on to the next part. So, okay, so there's the inspection. Point the kube config environment variable to the local kubeconfig file and test kubectl commands against the remote C3's cluster. Okay, so this isn't going to work because we don't have this kubeconfig file. Oh, so something happened here as well. I'm going to try going to this IP. It looks like I did a typo here. I did 172 instead of 127. So that makes sense that it would, because that's not a space they're going to allow. Connection to, what happened here? Unable to connect. Over, okay, so I don't have SSH set up on this computer. We're going to get a connection refused. I don't know why it's taking so long. Oh, because I did 172 again. This is why these early morning videos are so rare. There we go. Connection refused. And I might need to have to take a quick break here. Alright, so we verified this file, and we verified that it's missing, so I'm not sure how much further I can get. The next step is to install the Open Faas serverless platform on the K3 Kubernetes cluster. So you know what? I think I'm in skip mode. This just isn't that relevant. So I think I'm going to go into skip mode and just try to get through to the next section. Install Faas CLI on the local Mac OS. Create RBAC permissions for Tiller, which is the server component of Helm. Install Tiller via Helm init. Download, configure, and install the Helm chart for OpenFAAS. Okay, generate a random password for basic authentication to the OpenFAAS function as a service gateway. Deploy function as a service by installing the Helm chart. Note, the basic auth setup used here without TLS should only be used for experimenting/learning. Any environment of consequence should be configured to ensure that credentials are passed over a secure TLS connection. Verify the services running in the OpenFAAS namespace. Port forward 8080 port from the remote instance to port 8080 locally. Go to the OpenFAAS web UI and log in using username admin and password. Continue by creating an OpenFAAS Python function. Use the FAAS CLI tool to create a new OpenFAAS function called Hello Python. Inspect the configuration file for the Hello Python function. Inspect the automatically created directory. Edit handler.py and bring over the code that prints the current time from the serverless platform's simple HTTP example. The next step is to build the OpenFAAS Python function. Use the FAAS CLI build command, which will build a Docker image based on an auto-generated Docker file. Okay, Okay, tag and push the Docker image to Docker Hub registry so that it can be used on the remote Kubernetes cluster. Edit hello python.yml and change. Use the Faas-CLI push command to push the image to Docker Hub. Next, deploy the OpenFAAS Python function to the remote K3's cluster. Use the Faas-CLI deploy command to deploy the function. Use the Faas-CLI login command to obtain authentication credentials. Edit hello-python.yml and change the gateway. Because we are returning JSON from our handler, add these lines to hello-python.yml. Contents of hello-python.yml. Run the Faas-CLI deploy command again. If a code change is needed, use the following commands to rebuild and redeploy the function. Note that the Faas-CLI remove command will delete the current version of the function. Okay, so I do want to remove everything I've done so far, but this is just to remove what I'm skipping over right now. So let's see here. So we're almost done here. I'll move the bookmark and complete this section. Now test the deployed function with curl. Test by invoking the function directly with Faas-CLI. The next example will be more full-featured. We will demonstrate how to use the AWS CDK to provision several Lambda functions behind an API gateway for create, read, update, delete, CRUD, REST access to to-do items stored in a DynamoDB table. We will also show how to load test our REST API with containers deployed in AWS Fargate and running the Locust load testing tool against the API. The Fargate containers will also be provisioned with the AWS CDK. All right, so that's going to be it for this video, I think, about a half an hour, because I need to take a break anyway, so I might as well just end the video. So yeah, skipping things again, but it's not that big of a deal. I kind of wonder if I should just move on with this book and give it a rest, but we'll keep on chugging. I mean, we're on a grind right now, so we might as well so we're almost 3/4 of the way done with the book, and hopefully we'll get into writing that is more to stuff that is more doable in the lab, more interesting as well. Some of the machine learning stuff should be pretty interesting. All right, so that's it for this video. Thanks for watching, and see you in the next one.